Okay, so my name is Abhishek Pandey, and I used to work with Jan in my class. So he left last year. I still work with him, but now my advisor is Elena. So this is one project which we did on dengue. So there's a vaccine for dengue going to come, means they're having significant advances. So we wanted to see the impact of the vaccine when it will be introduced. So before I actually talk about vaccine or my analysis, I wanted to talk a little bit about the dengue. So dengue is a mosquito-borne viral disease of tropics and subtropics. It's recognized in over 100 countries. So this is a WHO map which actually shows the part of the world which actually which they have. Like you see, we have almost all of South America and then some part of Africa and India and Southeast Asia. So mainly it's very big epidemic in Thailand and South America. And this is the mosquito which is actually responsible for this dengue disease. So it is carried by Aedes aegypti mosquitoes, and this is the same mosquito which was responsible for yellow fever. And it's easy to recognize. They have white straps on their legs. So when a person gets dengue fever, it's the normal dengue fever is more like malaria or proper flu. So you have flu-like symptoms, you have headache, fever which lasts generally from 2 to 7 days. You have severe pain, loss of appetite, muscle and joint pain, and also rashes, diarrhea and vomiting. And these things happen in order of magnitude as it progresses to severe form of the disease. So dengue fever is the most common one, but people can also get the severe forms of the disease, which are like dengue, hemorrhagic fever, and dengue shock syndrome. So what happens in those two is that these symptoms really become severe. And there are although not many people die from dengue, but the DHF and DSS, they do cause some disease in Southeast Asia and also South America. Now the transmission cycle of dengue. So transmission is only by the female mosquitoes because they need the blood meal to produce the eggs. And so during the blood meal they acquire the dengue while biting an infected human, and during the subsequent blood meal they transfer it to another human. So people say that the actually dengue virus has come from the primates, from the forest, and then it reached the human, and then from humans it go to the urban population, and after that people travel. So it actually has been transferred all over the world. So, and one more interesting thing about dengue is that unlike other mosquitoes, the dengue mosquitoes actually they love to live in urban areas. So they would like to live near your house, wherever there is open water. Especially they love to live in clean waters. So they don't kind of live in dirty waters. So they if you have a flower pot and there is water which is not dirty, so they will live there and so on. So it's very difficult to kind of get rid of them. And they live very close to human population, so they transmit the disease more easily. Now, dengue has a very complex dynamics, and it is attributed because of there are 4 serotypes of dengue, and there is a very complex dynamic in that sense that if you get infection from one serotype and you recover from it, you get lifelong immunity to that serotype, but you get an increased risk of the severe form of the disease when you get the secondary infection. By secondary infection, I mean that you get an infection from one serotype, you recover, and if you get another serotype, you're infected with another serotype, then there would be increased risk of severe form of the disease. Means that is like dengue hemorrhagic fever or dengue shock syndrome. And this phenomena is also known as by biologists as antibody-dependent enhancement. And there are some hypotheses based on data and some clinical studies. So those are that the infection from one serotype also can cause a short-term cross protection. So you get infected with one serotype, you recover from it, for 3-4 more months, if some other serotype mosquito bites you, you're okay, you don't get sick. And third and fourth infections are very rare, so they have been rarely been reported. Now, there is like a lot of seasonality in the mosquito abundance in the case of dengue, which actually causes the complex dynamics of the dengue. And here is the data for childhood dengue cases from Thailand from 73 to 99. And you'll notice that like these are the 4 strains of the dengue, and at different points there has been like a different serotype which has been more prevalent. If see towards the 95 and onward, the dengue strain 3 is more prevalent, and like during 80s the dengue strain 2 is the one which has been prevalent more, and dengue strain 2 is the one which is considered in Thailand especially more severe form, which actually causes the severe form of the disease. Now, about the vaccine, we don't have any dengue vaccine yet, but there have been significant advances recently, and several vaccine candidates are going through different phases of clinical trials. And last year, one of the vaccine candidates, which was like people had a lot of hope with that vaccine candidate, it showed only 30% of efficacy, and it actually showed protection against 3 of the 4 serotypes. So, I mean, the assumption was, or the target was to have around more than 70% of efficacy. A vaccine with more than 70% of efficacy kind of considered good, and protection against all of the serotypes. But people are still thinking of using this vaccine because it can still help to actually decrease the transmission in the population, and that way it can actually decrease the number of people infected. So, and there are few more vaccine candidates whose result will come in like by the end of this year or next year. So, the dengue vaccine initiative community thinks that a licensed vaccine will come in next 5 to 10 years. Now, once the vaccine comes, the policy makers will have a question that how to allocate this vaccine in the population. And it would be very important to consider the impact of the vaccine distribution in the population. Now, what we think is, since there is seasonality in the dengue mosquito population, the dengue models may predict a transient period after vaccine introduction. By that we mean that there could be a time I introduce the vaccine for a short time of period, or probably 10 years, 15 years. There would be point of time when the incidence, or by incidence I mean the number of infection, will spike higher than what it was in the pre-vaccine period. Now, if something like this happens, then public, the people can actually think that vaccine is not working. It can also cause public panic and refusal to use the vaccine. And other than the public perception about the vaccine, there is one more problem for the health officials. If there is a point of time where suddenly there are a lot of people infected with dengue, then it can also pose serious problems by overwhelming the resources like health, hospital beds, and other things. So, what we wanted to do in this case was, we had kind of 2 objectives. First of them was to investigate the conditions when the transient spike will appear. And then second thing was investigating the short-term and long-term effects of vaccine introduction. And this was more focused on the fact that if transient spikes appear, does that mean that vaccine program is ineffective? So we wanted to see, okay, at one point number of infection has risen, but what about the short-term goal? What about maybe in year 2 there were no more number of people infected, but if I add the number of people, for that 5 years and compare it with the pre-vaccine infection, number of infection, does it do better or not? So we achieve these goals by simulating a simple dengue transmission model, and we vary the vaccination rates and vaccine efficacy. And then for the second thing, we compare the pre-vaccine and post-vaccine scenario. So this is my transmission model for the dengue. So in my model, I have 4 unvaccinated classes and 4 vaccinated classes, and one of them is recovered class. So, starting from the unvaccinated classes, my US1 is the compartment for the people who have no prior dengue infection. Means they are not infected with any serotype. So they get infected with a course of infection lambda, they become infected, and they recover with a course, recovery rate gamma. Then US2 is the compartment where they have one prior infection. Now, since they have one prior infection, their course of infection gets multiplied with sigma because now they have immunity from one of the serotypes. And they enter the second infection